Hi there everyone, my name is Jonathan Reyes and I'm going to be talking about how to unlock potential in your aquaponic data. And that may sound really boring, but I assure you by the end of this talk you're going to find a way to implement data into your system, and you're also going to know a lot of cool ways to unlock potential in your system. So basically we're practitioners. We're working on changing how the world views food production. We're creating these awesome, rich and nutrient dense crops that are easy to sell because they're so high quality, and yet we still need to understand it more. We still need to observe and have better diagnostic tools. We need to have clearer insights into what's going on inside of the system itself. And so that is exactly what data helps us do. Just to give you a little background, I'm the co-founder of Aquaponics AI, which is a tech company focused on powering the world with aquaponics. Basically, we want to give you tools and access to information and research so that you can do aquaponics anywhere on the globe in your local language. We're focused, it's a social enterprise, so we're focused on making sure that it's accessible and applicable to developing contexts and different economics that you're working with. And so we also have Talur, which is a sustainable agriculture company in Jordan, and this is where I live. I live in Jordan in the Middle East, and we work on system design here, as well as creating systems that generate profit for local communities and trying to liberate communities in that way. I'm also the member of 2 aquaponics boards, one in the US and one in Europe, and I'm proud to serve there. I'm really looking forward to pushing aquaponics forward in that way. There's a lot of policy change and a lot of things that are happening with the laws and jurisdictions, so I'm excited to see what happens in those arenas as we proceed into the next few years. Just to give you a heads up, like everything that I'm talking about is not a Silicon Valley bubble thought. It's developed because out of necessity, because we're out here, we're practitioners, we have farms, we needed this tech. And so this tech should be applicable to you. And the concepts that I'm going through today are equally as applicable to you. So this is what we're going through today. We're going to be talking about the deep dive. We're going from high level all the way down into the depth of commercial IoT solutions. First, we're going to be doing misconceptions about data, and then we're going to go into the actual value of recording. Why should we even bother recording our data? And then we're going to start off with 3 different ways to implement it, and that's right below getting into the water, below the surface of the water. We're going to start off with a beginner kit. What does a beginner kit look like? How can I start with that? How can I scale up to an intermediate kind of kit or hacker kit where I could piece technology together to get exactly what I'm looking for? And then you have the next step of a commercial IoT solution, which would be much more complex and involved. And so we're going to be looking at these different levels after going through kind of the misconceptions and values. So at the end of this talk, I really just want you to have 2 things in your pocket, in your tool belt. The first is that I can do this. That's the only thing that, if anything, you should remember from this, is that it's possible. There is a way to start with data. And the next one is to see what I could actually do. So we're going to be going through different setups, and wherever you are in kind of your scale of aquaponics, you can actually change that and upgrade your system with data. And so wherever you're at, you could see a next step after this talk. So let's just go through some of the misconceptions. This is actually a really hot topic because data is so new, and there's a lot of negative stigma related to like data breaches and hackers and all of these kind of things. But in itself, data is extremely valuable, and it has a way of telling a story and a way of unlocking potential, because you can see what's happening, where it's going, what could have happened, how can you prevent this in the future? What are the patterns that I'm seeing so that I can prevent this or see it, have foresight, or use it for business intelligence? And so data is very valuable, but there are a few things that keep us from actually recording data. The first one is tracking my data is hard. They say it's not worth it. It's I have to spend so much time and investing in just the right tech to get it right. So you could say, I'm not good with tech. I don't know where to start. I don't know what to do with the data once I get the data. But I want you to be reassured the value of data far surpasses any of the difficulty. So just tracking your data will give you the ability to learn about it later. But not doing it now makes it impossible to learn about it later. The other thing we often think about is that data is expensive, or tracking it is expensive. And I do know setups that are extremely expensive, but they are extremely technologically advanced. And so I would like to propose that there are cheap ways to record your data so that you can start to learn about it, and then you expand and grow as needed. A lot of people say, I don't have enough time. A lot of farm managers say this because they're just too busy running an awesome farm that they can't, record their water metrics, or they're just trying to keep things in motion. My business partner, Daniel Robards, he goes out to the farm and pulls out his phone, enters the data and all the metrics and the water parameters and everything. We have sensors, we have all of that connected, and it maybe takes a minute, maybe 2 minutes to enter all of that data. And so to do that gives us the ability to have so much more insight into the system, and it really only took a minute or two. And so that added value for just 1 minute is insanely valuable to the business and the overall functionality and operations of the farm itself. A lot of people want the end-all be-all solution, the implement and track everything that you need in one system. And that is actually very, very difficult. And it's hard to answer that question because you don't know how big your system is, how many sensors you need, how much data you need to track. And so this can actually stop you, in the complexity, stop you from actually starting. And so what we need to do is we need to think about what is the biggest need and how can I add value to my system by fulfilling that need. And so you may think I need to track pH and dissolved oxygen because those are the key metrics that I need to know about on a day-to-day basis. And then you can work towards all these other fancy sensors later down the road. And this is actually true. I mean, a lot of people are really, really good at diagnosing plants and seeing what's wrong in the system. And they say, my plants tell me everything I need to know. And so this is great for the 5% of the people that actually study horticulture and they understand the plants and they can kind of walk into a grow space and just feel what's going on. But for people like me, I'm technological. I need to understand this better. And also I can gain insights from other people that are horticulturalists that already know the patterns. And so I could look at logs of data and see this is when the temperature changed and this would be when the fungus happened and this would be whatever. You could analyze it better. And you could also see what happened if things went horribly wrong. And for example, if you're a horticulturalist and you're maybe new to it, you may not know everything that you're going to encounter. And so it's important to be able to look back at the patterns and understand what happened so that you can prevent it in the future. This is probably the biggest, basically a lie that we tell ourselves about data, is that we don't need to track it. And I guarantee you'll hear this anywhere you go, but I want to challenge it. And this is why, because this black background, it looks black, but it's actually a picture of us driving through the desert at night. I live in Jordan, and so I was talking with this Bedouin, and he was saying he can actually drive through the desert at night with the lights off, and it's pitch black. There's no lights. And basically there's sand dunes and there's pits and there's shifting sand and there's tall rocks that may fall at any point. And he claims that he can drive through that dark abyss and understand everything that's going on without any lights, without seeing anything. And while that's all great, I was completely scared. And so I think the takeaway is that for me to actually become like him, I need to spend 50 years sitting in the desert, understanding, listening to the sand move, listening to the wind talk to him and all these kind of things. I don't have that. And so what I'm trying to do is I'm trying to build a farm that is successful and profitable so that I can sustain my family, my community, I could bring better nutrients, and I could do all of that in a more effective way. And so tracking your data lets you do that. Ryan Leffers, he's a research scientist down in Kaust in Saudi Arabia. He says that without data, it's impossible to make informed decisions. And you can't evaluate at what actually went wrong. And then he says that you could actually talk to someone on the outside, and they can look at historical trends, and they could look at the different ways that the data has been moving, and they can give you better insights into what was actually going on. He goes on to say that it's like it's like driving a car without a speedometer. You may get by for a while, but you're never in the optimum point where you're just under the speed limit, but that's AKA the maximum productivity for your zone, but without the risk of crop failure, being ticketed crop failure. And so we're facing an issue where we're not in this optimal zone of growing versus crop failure. And tracking your data will let you obtain and maintain those levels within your system. So data itself tells a story. It operates on a scientific method. When you're analyzing it, you're using a scientific method. You're not using an opinion. And so we want to know exactly what our data is telling us, and we want to know more about the system. We want to know more about the environment, the pest management, the growth cycles and trends. We want to know how we can innovate and improve, and we want to forecast. We want to be able to see where we'll be, when our crops will be harvested. We want to know when the pests will come. We'll want to do reporting. We'll want to give people updates in terms of how much crop was harvested, how much crop was lost, how many fish died, how many times the pH dropped below a certain level. You could do all of these if you have the data. So data, in terms of telling a story, let's think a little bit about that. When you're doing fishless cycling and you're working through adding ammonia to your system, you often have to wait a certain amount of time, like 6 to 8 weeks, to let the water mature. You're letting the microbes convert the ammonia into nitrate. And so you're waiting to watch these certain variables change. And so this is actually a picture that you see, and it's quite common on the forums, on Facebook, on any social media platform where they're talking about aquaponics. They have this chart, and they're talking about my pH is this, my ammonia is this, and my nitrite is this. So you have this kind of snapshot of the system at this time. And that's very helpful, but it doesn't quite give you the full picture that you need. You need the story. You need to know what's going on with the actual system. For example, how much more time do you have until you could add fish? Or how long have I been cycling? How much ammonia have I actually added? Is it going well? Is it going poorly? Is it related to weather? Like, all of these factors can't be assessed when you only have a single snapshot of that point in time. But you might be familiar with this chart that is widely available, and it's basically a cycling chart for the nitrogen cycle. And so basically, as you add ammonia, over time, the nitrites start to show up with the different bacteria in the actual water converting it, and then it eventually turns into nitrates. And so you can tell over a certain period of time what is happening, and you're seeing the conversion, and you're seeing the direction and the trends, and you know about how much more time, generally speaking, you have until you could add fish, and you can tell how effective your biological processes are that are converting this ammonia into nitrate. You could also tell how much nitrate is available to the plants over a given time, and if there will be more or less. So there's a lot of really valuable insights just from this simple chart in an application, or like when you're actually tracking your data over time. Not only that, but when you're telling someone, I need help, this is also common. I mean, we're a global community trying to figure out aquaponics together, and you often send a question to someone saying, hey, something's wrong, my fish are dying, or my plants are showing some weird mutation or something like that. And people will always ask you for your water quality parameters or other metrics as well. And so you need to pass over the pH, the ammonia, nitrite, and then maybe other things as well. But this is the most common. And so when you send them this, it's great. They have a snapshot of that individual picture. But if you're going to an expert, they're going to ask for a log of your data. They're going to want to know what's been happening over time. They could tell if your nitrites have been spiking or something has been going on outside of the general snapshot of where you're at. And so there's more of a story that needs to be told with the single snapshot of data. And that's where you get to see, trends and different insights that come with it. Tanya Sawyer, everyone might know her. She's talking here at the conference as well. And she says that we find tracking data essential, an essential part of our daily farm operations. By recording water quality parameters, crop rotations, nutrient, pest regimens, and so on, and so many other things. And they can maintain food safety compliance, which is something that we haven't talked about, but to have that level of compliance, you can have your data support you. She goes on to say that recording this data helps us with forecasting. It helps us production levels and trends and warnings and financial analysts and cost controls and informed decision making. You can understand the positive impact or the negative impact or the overall sustainability of the entire business. So this is actually a great application of data in a commercial setting. And so you could see as you grow, the data becomes more and more essential so you can maintain compliance and understand more about the business, not just the system. So let's just talk a little bit about what can you actually do with the data? What are some of the best case scenarios? This is only a short list. It's really countless and where your imagination stops. But basically you have efficiency of feeds, nutrients. You're not overfeeding your fish if you know exactly how much they're going to eat versus the temperature and the different water quality parameters and their food conversion ratio and all of these kind of things. When you're talking about clear crop scheduling, you'll know exactly when to plant something in relation to market trends, to weather trends, to everything else going on around you. It'll help you when you're talking to someone in urban policy or maybe a more national policy maker, that it will convince them in certain ways, one way or another, based off of your data. Your compliance can be automated because you can produce reports that show exactly what happened to this crop at this time. You can prevent pump failures. For example, you can start to detect sounds from pumps as they are working, and as the sound changes, it usually means something is wrong with it. And so instead of losing fish overnight or losing your irrigation for your plants or something, you would be able to switch out the pump in time. So there are countless ways to use data to improve your actual system. So all that being said, let's just talk about how can you start with where you're at and scale with your goals. Basically, we're going to look at where you have your individual aquaponic system. Maybe it's a commercial farm, and that's great. And maybe it's your own backyard, but you actually have a pretty big backyard, or maybe you're just starting out. There's going to be a spot for you and a way for you to grow and scale depending on where you're at. So let's just start talking about the beginner's kit. And we have the intermediate hacker kit and the commercial IoT sensors. Those are the 3 levels of integration. And so each one becomes increasingly more complex. And so when you have a beginner kit, your risk is extremely low because you can just stop adding your data. So you basically just stop tracking, or you understand very few things about the system itself. Your cost is also low because you're using probably a API test kit or something. And your time commitment, it's probably once a week, maybe twice a week. You're recording that data. And then your complexity is also low because you're just testing the data and seeing what happens, and then you're recording it. The volume, you're maybe doing 10 records per week. It's really easy to jump into this level of data tracking. Over time, you're going to find a lot of really cool charts you can make because you're looking at your ammonia over time and your nitrate and nitrite and your pH over time, and that's exciting. When you get comfortable enough, you can actually jump into the intermediate hacker level, and that's when you basically, the most common way is to buy a Raspberry Pi and buy some sensors that are actually applicable to you and try and make it work. Try and get the sensors to plug in to the actual Raspberry Pi device, and then get your language set up and do all the communication with it and track that data over time. So you could track it, every 5 seconds. So that risk level is also low because you're doing what you want to be doing, and it's not mission critical. It's more of a hobby turning into more of a commercial solution. And so your cost is also minimum because you're only buying things that you can afford. You don't have to go get this massive loan to get these tracking devices so that you can actually invest in it. You don't have to hire a programmer if you could just go online and find tutorials. And your time commitment is also very low. Because you're implementing it yourself, you have the actual knowledge to adjust and tweak. And so it is more of a commitment than being a beginner, but it isn't overbearing. It's not a lot of work to actually get a system up and running with a Raspberry Pi. The complexity is still low because of the next one, and we'll get into that in a second, but the data volume is medium. You kind of have to understand how much data you're going to be collecting at this point. It's not a lot. It's about 6,000 records per day, which is fine. It's a very low amount, but it's enough to give you really nice charts and understanding of your system. At this level, your sensors won't be as accurate, or they may need to be calibrated more often. And so that's where it also adds into your time commitment. When you get into a commercial setting, things are exponentially more involved, and you need more specialized equipment. The risks are higher because they're probably mission critical in terms of if a pump goes out and you don't know about it, then crop dies, fish die. The cost is extremely high, so your sensors need to be accurate so you have a better understanding of what's going on. You can't afford to have a bad pH sensor telling you within 2 plus or minus 2 points ppm of your actual value. You need it to be as accurate as possible, and so that comes at a high cost for implementing a commercial system. The time commitment is also very high because you have to be able to know how to calibrate and to maintain and to clean and to know if there's something wrong. You need to implement all the sensors everywhere. And I put this picture of the Iron Ox just because it's so impressive that this bot can run around carrying tables and actually fully automated harvesting system and growing system right there in the greenhouse itself. And so that requires a lot of sensors. You need to be able to see plant deficiencies and if water flow and all of these different metrics that you wouldn't normally track with an intermediate setup. The complexity is also pretty high because it's talking to each other, and you're probably going to get maybe 300,000 records a day at the very minimum. And so you're getting a lot more data, and you need to understand where to put that data so you can analyze it. You can't just throw it in Excel and look at it because it's going to be too much and it'll actually overthrow the system. The data volume actually gets much higher because you'll be tracking it at a more frequent rate. So with an intermediate setup, you may be doing every 10 seconds. In a commercial, you can do every 10 seconds, but you can do every second or half second, or you could see all of these different ways that you could track. So let's just go through what a beginner setup looks like. We have our beginner setup. So we have our manual testing and chemical solutions. Very simple, straightforward. You put the drops in, you shake it up, you wait 5 minutes, and then you look at the actual readings and you try and translate it into a color or a number. And basically you just record that in Google Sheets or our software, for example, and then out of that you get charts that you could look at. So over time you'll see your pH has been going up and down, and it trends down, and then you add some whatever your different mix to the system, and it raises your pH a little bit, and then it trends back down. And so when you could see these trends start to happen, and that's really exciting. So that's a fun way to get involved in it. And then you get into the more intermediate setup where you have the manual testing. So you have maybe a clipboard or something that you're going around checking all the bricks tests and the dissolved oxygen. Those are expensive sensors, like the dissolved oxygen, and you want it to be accurate, and you don't want it to be off so that your fish die. So you want it to be accurate. So you need to pay some money for a dissolved oxygen meter. So otherwise, you can actually just manually test it with a strip or something. That can potentially be more accurate depending on your guess and the number. But the implementation for an intermediate setup would include sensors. And so you're adding sensors that are applicable to you and you feel comfortable implementing. So you can take a sensor from somewhere and put it on a system. It's going to be a cheap to medium level price, and you're going to add it to your Raspberry Pi, and you're going to track the data locally or using ThinkSpeak or Grafana or whatever it might be. And then you create charts, and you look at these charts and trends, and you could even start to do error tracking and alerting if things go wrong. And so those are the two basic setups, and now I want to talk about a more commercial setup and what that would look like. Basically, what happens is you're adding much more complexity and brokers and different ways to track errors. And if something goes wrong, you need to have backup systems. And so it gets much more complicated. And this is actually a simplistic view. So basically, you have sensors throughout the greenhouse tracking any number of things from humidity to temperature to dissolved oxygen, ammonia, pH, any number of things. And it's sending all that data to a central hub, and that hub is processing the data, getting ready to send it to the cloud. That hub may actually perform other things, like it may close the shades if it gets too hot, or if there's too much light. If you have a light sensor and there's too much light, it may pull the shades out. It may open the roof. It may close the door. It may do any number of things based off of real-time data that it's receiving right there on the hub. And then every now and then it sends that data into the cloud so that you can access it with your phone or your other dashboards or something like that. But that doesn't handle all of the use cases. There's also the manual testing for like bricks. So you want to test your bricks levels of plant sap and whatever it might be, the juice in fruits or whatever. And so you need to record that somewhere. And so you record it manually, and then you get it into the spreadsheets, and then you align it with the same data that you have from the sensors. And then you could do all sorts of cool stuff like create charts and send out real-time alerts if anything goes wrong, if your pump fails or if the water flows too low. You can actually get alerts on your phone or through some sort of service or webhooks or anything like that. You can get all of that provided to you. So commercial setups are much more involved, as mentioned, but the payout is much more control and insight and potential to understand and innovate because you have so much data you can analyze. And as you begin to see, like, for example, I didn't put in here, you could track weather patterns, so you can get your local weather station to give you data. And you can also store that to correlate your trending lines. So you could see the pH and how it changes based on the weather, based off the internal greenhouse temperature or whatever it might be. Here's just an example of what you can actually track inside of a greenhouse. And this is by no means a conclusive list. There's tons of things that you can track on a daily basis, and you can learn how to add more things to your system over time. So you can track weather, humidity, light sensors. You have your indoor sensors for humidity and light and different air, carbon dioxide. You can check soil. Some people use soil sensors to track humidity or actual, like if they're doing aeroponics, they'll see if there's moisture on the roots. And if you're using equipment to control it, you can control all that stuff with fans, with roofs, rooftop, light, shades. It's really endless in terms of what you can do. And I think that it's really interesting now is that you're seeing a lot of automated greenhouse competitions pop up, and people are trying to completely control everything without a single person entering the greenhouse. And so this is all done by this technology. It's the same technology across the board. And so once you start from a beginner setup, you slowly progress into these other areas as well. So you don't start at this level when you're just beginning aquaponics, but I encourage you to start with a water metrics setup, and then you slowly progress as you feel it applies and adds value to your system. So I just want to say thank you, because I am really passionate about this, and I think it'll add a lot of value to your business or your backyard farm. And I honestly think that tracking data is the way forward to change legislation, to change the way we think about food, to understand more about our systems and how to improve aquaponics. And it'll honestly give us a lot of validity when we're going to investors or when we're going to expand our business and we're talking about projections and financials. When we have data to track, we can actually know the direction that we're going. And so I would encourage you to check it out. And if you're looking to do the IoT stuff, I have a link right there, IoT sensor list. It's just a compiled list of the sensors that we found over time, and we'll keep adding and updating it as we talk to different vendors and find valuable sensors that we can add to our system. Feel free to contact me at any time, and I look forward to seeing what you grow. And I'm excited to be here today and to be able to talk with you. So have a great day.